Hello everyone, welcome to another video. And in this video I want to show you again the provision script. This time I did create a couple of scripts according to the customer requirements. So again, this is one more custom script which you cannot find on my website. You cannot purchase that script in that list of scripts. But if you have a need for something similar like what I will show you, you can always contact me and we can find some solution. So over here we can see a list of requirements. So at first the script must work in the German user interface for the Revit. When you are using German user interface inside the Revit, all the category names are different, all parameter names are different, and also the customer have dedicated custom parameters. So you must integrate all of that and you must test the script inside the Revit user interface on German. I do not know German language, so for some options it was hard for me to test the script, but eventually I did learn to handle German user interface inside the Revit, so I think that I can work similarly efficient like in the English user interface. So that is the first requirement. Second requirement is that we must create a script which will work for the walls and the floors. So for that purpose I did create separate provision families for walls and floors. On this MEP side, the script must work for the cable tray, duct and pipe. The user can force, over here on the right side you can see what is the user interface at the moment when somebody runs the script. So for example, default behavior for the script is when you run the script for the duct and pipe, provision will be round because we are dealing with round elements. But you can click over here on this rectangular checkbox and you can force script that even for the round elements create rectangular openings. Okay, this script one have part 1 and part 2. The workflow is that inside the MEP we should create provisions, we should assign some statuses, and then inside the architectural or BAU model we should run the script 1.2 which will then copy all the provisions with the status OK and cut the walls and floors. So this script 1.1 works in MEP or TGA model. Also, you can see the complexity or simplicity of the script. You can see how many nodes I did have. Also for pipes, we need to use predefined data. So the customer did create two Excel files, one for rectangular openings, one file for round openings. So when you want to create openings for pipe, the script needs to go into the Excel file to find a match for the pipe size, and in that way it will populate dimension for the provision size. Also over here user can use the offset. So if you have, I don't know, duct which is 600 by 400, you can say that you want to have an offset of 50 millimeters by each side, and that will enlarge the size of the provisions for 100 millimeters in total. As I did say, the voids must have a status. Also user have some predefined custom parameters, and also every niche provision that the script creates need to have this unique ID that is a sequence, and it has some logic inside the script how that ID will be formed. And now we are inside the model. This is again TGA or MEP model. So what we have over here, architectural elements are inside the Revit link, which is called BAU. On German that is architecture. As I did told you, for the script 1.1 we will run the script inside the TGA model. So we have some Luftkanal, those are ducts. We have round and rectangular ducts, we have pipes, and we have a couple of cable trays. And now we will run the script 1.1. At first we need to select TGA or MEP category. So in this case we will select ducts. We don't want to force provisions to have a rectangular opening. We need to select a link from which we will took the geometry of architectural elements. For architectural category, we will select one dev, which is a wall. And now we have a couple of custom requested parameters. One of them it's a status. Status can be okay, not okay, or work in progress. And for the offset, I did leave 50 millimeters default value. Now we can take a look that for the round elements, we have created provisions. So the dimension of the duct, it's a 300, and then when we take a look what is the diameter of provision, because we are adding 50 millimeters on each side, we did enlarge that dimension for 100 millimeters. The thickness of the provision is the same like the thickness of the wall, and as you can see, we did create unique ID for this provision. Now for the rectangular provision, over here we can also see what is the size of the rectangular duct, and we can see that we did again increase that size by 100. Now we will run the script for different categories. I will speed up a little bit this process just to show you that we can also create provisions for other categories. And okay, we did create provisions for the cable trays. Over here also we have a wall which it goes by some angle. Again, the thickness of the provision is the same like the thickness of the wall. Also over here for the pipes, we did force that we want to create rectangular openings, and as we did say, those dimensions are controlled by the Excel. So at first we need to see what is the size of those pipes, and we have 65 nominal diameter and 100 nominal diameter. Now inside the Excel, when we want to check what rectangular dimensions we need to have, for 65 nominal diameter we need to have 200 by 200, and for 100 nominal diameter we need to have 300 by 300. And now you can see that we have those dimensions inside the model. Over here you can also see that we did create provisions between MEP elements and the floor for rectangular ducts. Over here we also have some pipes which are going through the floor. Just to show, we will also test the script with those categories. So MEP category it's pipe. In this case this is a category name for the floor on German. We will change the status, and that's it. And now as you can see, we did create those provisions. Again, their dimension is controlled by the Excel file. And as you can see, the status is like we did select in the user interface. And okay, now I will save this model and we will go to the bow or architectural model, where we should run the script 1.2. So over here, walls and floors are our elements, and when I click on the some installation, those installation belong to the TGA Revit link model. TGA is the same as MEP on English. So now we will run the script 1.2, but before we run the script, let's just cross-check those customer requirements. So again, the script must work on the German user interface. It needs to be run from the architectural or BAU model. And now the way of working for this script is that the script will go through the Revit link. It will check all those provisions that we just created, and only for the provisions which have a status OK, the script will copy those elements and cut the walls and floors inside the model. Let's see how that script works. So over here we have a very simple user interface. We need to select from which Revit link we want to retrieve those provisions. So it's a Revit TGA link. We need to say what is the parameter name which we did use in the status. We should, prior to running this script, check that inside the Revit link. I didn't check it over here, but I assume that is the correct parameter name. And finally, we must also tell to the Dynamo where is the root, where Dynamo can find Revit family template files for the generic model category. Why? Because we need to recreate those provisions in our file, and for that we will use generic model family template. Set values, and now the script will create those elements and automatically it will cut the wall and floors. And now if we turn off the visibility of TGA model, we can see now that we have openings inside the walls. We don't have openings inside the floors because probably for those provisions we didn't say OK for the status. I didn't show how those walls were before we did run the script, so I will go undo. I will turn off the TGA link. So at the beginning we did have those elements and their visibility was like everything is solid, there is no openings. And now again, if we turn on visibility on MFP file, we can also check if those provisions on the floor have the status or OK or not. They don't have the status OK, and that is why the script will not create those provisions and cut the floor. And OK, we will run again this script just for you to see that the script will create those elements and cut, in this case, those walls. That is it. We will turn off again visibility of TGA model, and that is basically it. Again, this is a custom script created for the German user interface. I will also create separate videos for the script number 2, 3 and 4. Those scripts are also dealing with IFC. Probably it will be more interesting to you to take a look how those scripts work. But again, thank you for your attention, and if you have a need for a similar script, you can always contact me. Thank you for watching. Bye.